Hello everyone. In the previous video, we understood what is an operating system. In this video, I will tell you why do we need an operating system. As you can see in this visual, and as it was explained in the previous video, that operating system acts like a manager. It will manage all the things, everything that is needed in a device, such as a computer, laptop, phone, or anything that we generally use. Without an operating system, everything fights for itself. For example, as you can see, the browser would need the CPU. Let me change. The browser needs the CPU. Music player also needs the CPU. Any game that you might be playing, that also needs the CPU. And the document editor, such as Notepad, also needs the CPU. Similarly, at the same time, they might need RAM, storage, printer. So the result would be very chaotic, error prone, and possible data loss without the operating system. So, operating system is a resource manager protecting the device, its resources, as well as controlling the whole system in a way that we can use. We as users, as well as the developers, everybody of a device can use it very efficiently. It's very well explained in this diagram that from the left side, a very chaotic something is coming. OS acts as a shield and then segregates them in either files, the hardwares are linked to the software or the applications that we might want to use. Here you can see the same example as it was given with the help of an office. In a school, if there is no principal, everything would be very chaotic. The students don't know which class to go. There would be lectures, but we cannot guarantee whether they will be complete or not. The same class like the class teacher is coming, two class teachers are coming to teach the same class at the same time. Two different students are coming there. Some people are taking off this printers, screeners, and all the other things. If there is a principal, he would direct everything in a manner. As you can see here, a queue is there formed to maybe use the library resources or the labs. Different types of classes such as chemistry and geography are being taught at the different times if there are shortage of resources or something like that. So everything is well managed. Here you can understand, school analogy, that a principal is like the operating system who is managing everything. Classes are the applications such as Docs, Google Sheets, PowerPoint, image viewer, music player. Teachers are the CPU time. There is timetable for everything. So teacher would be the CPU time. Classrooms would be RAM, the resource that would be used for any execution. Record room would be the disk or the database in which everything is being stored. Projector is the shared device such as printer or maybe scanner or something like that. Timetable is the scheduling that the teachers, the CPU time or the processor would be using that particular scheduling to schedule its classes and teach. School rules would be the protection so that unauthorized access or people who are not studying there or something like nuisance or something like that could not happen. Before OS, there is a very uncontrolled access in the device. As it was explained, I think 2 or 4 slides earlier as well. Different applications are arguing or conflicting for the same type of resource. For example, everybody needs the CPU, RAM, storage, printer. So the problem with that is CPU conflict will be there, memory override, such as if I am playing a game. Let's say we are two people, A and B. A is playing a game, B is doing some editing on that. A is a processor, B is a different processor. A is a process such as game, B is a documentator. A game saved, if I am in some checkpoint in that game, it should not be saved in a place where the document is editing currently, right? But if there is no control, there is no management, that could happen. This using is called memory override. Another issue that could be disk corruption and then mixed device commands. For example, printer might not print the whole paper, just a part of it, and then maybe stop or do something else. With OS, the control is very organized. Every application has to go through an OS which will schedule, provide file system, have device drivers and security as well for the resources to be used efficiently. Now, what is CPU scheduler? CPU is the processor, as we say, central processing unit. Central, let me change my marker to something dark, maybe red. Yeah, central processing unit. This decides who would be for what amount of time being processed in the system. For example, a scheduler is one who schedules the programs. For example, a music player application would be scheduled for 1 second, 1 millisecond. A game would be for 1 millisecond. Antivirus app for 1 millisecond. This is the ready queue. I will explain all of this in the subsequent videos, since the first lectures are just to explain what OS does and what are the terminologies that we might get in the course. CPU scheduling gives each ready process, such as this is the ready queue in which the processors are waiting for their turn on the CPU, then moves to the next. The scheduler gives time slots to all the different types of processes that have come in the ready queue. This is the ready queue. Who runs CPU? When? Based on a time slot. For how long? It was given here. Who runs next is based on the ready queue. Running currently, as here it is shown, is the browser. It is also running for 1 millisecond. In this particular scenario, 1 millisecond is the time slot. Everything is getting 1 millisecond. This need not be the case for you, what you are using right now in your device, but this is just an example. Things could vary based on your scenario or what you are using. So there are three types of queues. First is running. The process that is being executed currently is in the running one. Here, this is the browser app. Ready is the ones waiting. Blocked, which are not ready yet. Okay. So now, after understanding how does this OS manage the CPU, we should understand memory management. For this case, I'm using just the RAM, not the ROM. I'm not using ROM here. Just random access memory. Memory management is used for allocation of data, allocation of memory for processing, tracking, protection, and then recover. If there is no memory protection, then the browser data could overlap on the music data. There could be overwriting, and that would be a lot problematic. Instead of that, what OS does is it will allocate different spaces of memories. Okay, let me just erase this one and explain a bit better. Let's say I have a working desk. One space will be located for music. Another space would be allocated for browser. One is for maybe game, and one is free. So this free would be given for another thing that could come up here. This is done with the help of operating system does this. Now, when you want to print anything, as this is the case of using an hardware with the help of an OS. An application wants, maybe you pressed Control plus P in Windows, application goes to the OS operating system. It operating system checks the printer driver. Driver are special softwares or requirements for each hardware to be working in that particular OS. Then the driver goes to that particular hardware to say you have been assigned with some work and you have to do it. There are two applications, application 1 and 2, both are giving the job. OS puts job 1, 2, 3, 4 if there are someone in the print queue. As written here, OS organizes the jobs in the right order, sends them one by one, converts the job into a format that printer understands. Jobs are printed in the correct order. If there was no OS, the problem would be both the jobs, job 1 and job 2 as shown here, would demand the printer, and the issue would be somewhat so chaotic that job 1 would be half done and then job 2 would come up in the place, and we don't want that, right? So moving on. Now, print jobs are queued. This is just one example of a hardware, how is it being used. There are other hardwares as well, such as webcam or an optical device such as our mouse or something else as well. So those are worked in the same way. The driver OS works with the help of that particular device driver, and then that device is being used. Now, here we can understand, we have to understand what is an authorized access and what is not authorized access. There are two people, one guy and one girl. The guy wants to access some files or folders. He has the password of that particular file and folder. He went to that particular place in the system, put up his ID card showing this is the password and I am authorized to look at the information in that folder. While the girl was not, because she did not had access. OS manages this. Operating system helps us in managing the access. If any error is found out in the device driver, that also is sent with the help of OS, or the result to the application through the OS. Now you can see here we have different types of applications being open up. First is the web browser, next is the music player, next is file download, antivirus scan, document print, everything. So what CPU does is give short amount of time slices. Time slice means literally cutting up the CPU time in chunks so that one particular process, if needs the CPU, if processing is to be done, it will get the CPU for that particular amount of time. Parallelly, memory management such as RAM, if available, or as you can see there are 5 processes. So one on the left, blue one, I'll just mark it down. This one is for the web browser, maybe this is for the music player, this is for file download, this is for antivirus, and this is for document. So this is the amount of RAM that is being occupied by those processes. Next, input output coordination such as disk, any external hard disk that you might have put up, or SSD. Network is for the internet purpose or the printer. So the network adapter having the driver would be coordinated with the help of the OS. And security permissions such as whether a particular printer is being accessed by just either one at particular time one user or something like that. Okay, so in Windows you might see a task manager like this. The same is there in Linux as well as the Mac OS. You can see all the things that a particular OS is being managed. There are some myths regarding why do we need an OS. First, the myth is OS means only desktop and icons. This is not true. This is just a part of the operating system, not the complete operating system. The OS also manages process, memory, files, devices, and security. Myth number 2 is apps control hardware freely. That is not true. As explained earlier, OS manages applications help to use the hardware resources. Myth number 3, OS creates unlimited resources. That is not correct. OS manages limited resources very efficiently. Myth number 4, every application gets its own CPU. No, it is not correct. Processes share CPU through schedule. We might feel like every process is getting its own CPU, but that is not the case. This is the beauty of the operating system, how well the OS is the invisible manager that keeps everything running smoothly and securely. So, if somebody asks you next, why do we need an OS? I think you are confident enough to tell why do we need an OS and what is an OS. In the next video, I will teach you hardware, software, and operating system, how all of these layers work together. So please like the video, share the video, and subscribe to my channel. I will be uploading the whole operating system course in this particular playlist. So please press the bell icon so that you will get a notification whenever I upload the video. Thank you.